Welcome to Analyze Security Hub with a serverless AI agent. I'm Stephen Kuenzli, and today we're going to talk about how to reduce your toil of reviewing and triaging cloud security issues by automating that review with AI. I'm Stephen Kuenzli, founder of K9 Security. And at K9, we simplify AWS IAM and cloud security generally so that teams can focus on fixing issues instead of analyzing and finding the problems. So I also wrote Effective IAM for AWS, and I'm an AWS community builder focused in the security space. In today's agenda, we're going to talk about the problem of why is it that keeping on top of security issues is so hard, and propose a solution that's come out of real-world conversations to deal with that problem. Then we're going to demo a first step towards that solution, and then we'll dive into the architecture and code of that solution, and then wrap up with Q&A. The one thing I want you to take away today is that you can build useful agents today. No, it's not perfect, but neither are your existing processes. And so to the extent that we can automate the undifferentiated heavy lifting of reviewing issues for cloud security teams, platform teams, DevOps teams, etc., that's a win. We can free up our time to focus on more valuable things, in particular, making a decision based on that input and then going into actually fixing something, which is where the real value is. So let's dig into the problem a little bit and set the context. So, everyone wants to be secure, and no one wants to let customers down or be in the news for bad reasons or spend time cleaning up a mess. But let's face it, a lot of cloud security is just so tedious. Every day, analysts are reviewing, prioritizing, and routing issues throughout the org according to their priorities, the organization's priorities, and then helping people, hopefully, do something about them. And analysts need a lot of knowledge about cloud security and the org in order to get that job done. So in conversations with some of our customers, I was speaking with a VP of engineering at an org with 500 engineers, and he said, if I can hire a cloud security agent to watch all my AWS accounts and report findings, some findings to Jira, and other things like bring people into the loop, then this could get really interesting. And they're already experimenting with MCP servers for Jira and AWS, and so he thinks this is possible. And perhaps you've heard this from stakeholders at your organization. And maybe you have, maybe you haven't, but I guarantee that there are key people in your organization that are at least thinking about this right now. So let's explore what we can do here. We're going to talk about two big use cases today. The first is interactive analysis, and the second is a daily or periodic review and prioritization. We're going to focus on the interactive side because it kind of breaks the problem down. You can see it happening step by step, see the solution step by step. And we can talk about each of those steps. Just know that basically the code underneath all of this is all the same. So technically, the high-level solution looks like this. We've got a couple of clients, the AI chat app, like Claude Desktop in this case, or ChatGPT. We can use that for interactive analysis. We've got automated workflows or automation that might be running in a Lambda or some other application that can be triggered by an event, whether that's like a CloudTrail event or it's running on a schedule to go analyze things. You could also trigger the automation to go do something based on something from your CI/CD pipeline or some other incoming request. But those clients, they talk to AI components running on Amazon Bedrock Agent Core, which is a new service from AWS. The components we're talking about are an MCP server or an agent that is exposed essentially like a Lambda function would be, that you can send a prompt to this agent component running on the Agent Core platform, and it returns a response to you. Those AI components are talking to the Security Hub service to get findings. So the Like the chat app is not talking directly to the security finding service. They're interacting with the components, the AI components running on Agent Core. Those components are built with or on top of the Strands Agent framework, which is an open source AI component building framework that comes out of AWS. One of the things I really like about Strands Agent is it's built so that you can start simply, but yet scale to all the fancy enterprise AI use cases you may have heard about, but that you probably don't need, actually. So it's great that you can actually start simple and get something up and running and deployed quickly. A little bit more about Agent Core, since this is a preview service, so it's brand new. Agent Core is designed to help you deploy and operate AI agents securely at scale. It's a serverless platform for AI agents and MCP servers, so much in the way that Lambda is a serverless compute service, and so is Fargate, where you package up a container and send over to Lambda, run it. Very similarly, you package up, there's tools in the Agent Core world to help you package up your agent or your MCP server into a container image, send it over to Agent Core, and it runs it for you. You can use any agent framework or model, and AWS is using Agent Core to take up a lot of the security and operational responsibilities that you have. In particular, some of the things you get from Agent Core are you get authentication to your agent and MCP components with IAM or OAuth 2. You get isolation between client sessions. Like you get a new instance spun up and Agent Core takes for each incoming client. You also get session persistence and affinity and so forth for free. And you can execute workloads for up to 8 hours. There's a whole bunch of other stuff that I'm not going to talk about here, but definitely if you're architecting an AI agent or MCP deployment, go check out Agent Core and see if it makes sense for you to adopt it. So let's get into agent and tool architecture a bit. So agents can be provided new capabilities by giving them tools, and you can think of these essentially functions that the AI agent can call with parameters. Okay, and agents work best with a mix of low-level and high-level tools that they can compose to accomplish a given workflow. So we have two low-level tools here. One, to get security findings from Security Hub, and second, an analyze security findings tool, which takes a first pass at just filtering and prioritizing the issues or findings that we're going to focus on that the AI should focus on. And importantly, this is a place where you can bake in the rules of your organization, like you're going to prefer, like you're only going to look at criticals, perhaps criticals and above, or you're going to prefer looking at issues related to PCI compliance or HIPAA compliance or whatever. You can bake your preferences in here. Third, there's a high-level tool, which is a security agent. So we've deployed this as a tool, but it acts as a security agent. You can think of it as like if I were to codify my favorite security team member into like an AI prompt, what would it be? Well, it would, you would construct that prompt, and then we're exposing that as a tool that Claude Desktop or ChatGPT can use to get advice. Importantly, this is a place where you can define your rubrics and frameworks and how you operate and how you talk within your organization about security, and you can give it your own personality. So with that, let's see a demo of this working. So I've connected Claude Desktop to the MCP server running on Agent Core, and let's ask it, what security tools does it have? It's an AI agent, it can tell us. So it's identifying the 3 tools that we just talked about to get findings and so forth. And importantly, it has identified a workflow that it can use these tools. It can retrieve findings from Security Hub, analyze them with the analysis tool, and then consult with the security agent for recommendations. So let's go ahead and do that now. Let's ask Claude to go review the Security Hub findings for our demo account, our test account that has vulnerabilities baked into it. First, it is querying for findings from Security Hub, first severity fatal, then critical, than high. And it bundles up all those findings and it sends them off to the Analyze Security Findings tool to discover which are the most important findings that we should actually focus on. So this is the part of the process that actually takes the longest, because it's taking the data that came back and it's writing it back into the model, and honestly it just takes a while. So and there's another challenge too, because there's so much data, we faced context overflow issues. So one of the things that we did is we optimized the Get Security Findings tool to distill the findings, which are in OCSF format. We distill those findings to have just the data that might be used in the analysis tools process for evaluating things. And it's going to return a document that says, okay, these are the issues I analyzed. It's going to identify the most important findings, and then some statistics about, what compliance and resource types, compliance frameworks and resource types were involved. And then the Claude desktop agent took that JSON document and transformed it and summarized it into a markdown document and sent it over to the agent for review. And the agent, our security agent tool, let me just run this back a little bit so you can see it. Our security agent tool returned an assessment identifying what should be done immediately, and it provides an executive summary, some details, and some next steps. So based on that response, Claude Desktop interpreted that and is saying, here are the critical issues, here's what you should do immediately, and then it provides a little remediation roadmap for what we should do. And it turns out, we need to address a couple of public resources, S3 buckets, KMS keys, as well as root MFA. Now, I'll call out one thing that's kind of interesting. It also estimated the effort involved in doing that. Now, that didn't come back from the security agent tool. Claude was being helpful and made that up. So I'm just calling that out because it's an important thing to keep in mind, that when you don't control the system prompt in an agent, that it may do unexpected things. It's going to go and act on its own. We can talk about that a little later. So let's dig into the code. All of the code for this presentation and demo is available in the security agent demo repository in the K9 Security IO GitHub organization. It's Apache license. I'll call it two things. One, it had two goals. One, be useful, like it should actually provide useful recommendations, act like a security agent or a security analyst and provide useful recommendations. Two, has to be simple enough to be able to talk through in a demo. It's not production quality, but perhaps you'll walk away thinking this is something useful as a starting point for our own work, whether that's in cloud security or reliability or cost management or what have you. So with that, let's go back to the security agent tool, which in the fast MCP framework, you can annotate a Python function with this MCP tool decorator, and that means it's going to be exposed. It's a function accepts a message and like an arbitrary prompt, like go review these findings and give me an assessment. And the way that the agent knows what the tool can do and is from a tool description, which is populated from this comment. And importantly, this comment says, it's a security agent. And it also gives guidance on when and how to use a security agent. Use the agent tool to review the output of the Analyze Security Findings tool, or you can analyze a small set of OCSF findings directly from the Get Security Findings tool. And this description is how the agent knew to combine the tools together and to create a workflow. And basically when a message comes in, the string is passed along to the security agent function. Well, what's that? Well, that's our security agent. So the security agent is actually very simple. It's a configuration essentially of a Strands agent object, or an agent object from the Strands agent framework. So we configure the agent with model and a couple tools and then a prompt. So this is mostly prompt, and we declare what the responsibilities of this cloud security expert are, and we're just configuring how this thing should act. And importantly, we can do things like describe how we want the analysis reported. So, we should be focusing on fatal, critical, and high severity issues first. And, like on the assessment, should have 3 sections: a summary, details, next steps with remediation and immediate next 7-day and next 30-day timeframes. And, it's got a personality of some sort. It says, it should be it should maintain a professional and helpful tone. Now, if your team communicates all your security findings with memes and jokes, like, you can have your agent do that too. This should fit in with your team and make sense in your organization. So moving on a little bit, the Security Hub Findings tool. This, again, is a wrapper. It takes a lot of parameters that are focused on how to filter findings. And importantly, the tool description describes the arguments, not just their names and what they're supposed to do, but their allowed values. So in the case of Security Hub issue filtering, you need to specify the status and the severity with the right names. It needs to be new with a capital N, and critical should be spelled with a capital C. And of course, our tool can make this more robust by handling different cases and stuff like this. But the key point I'm trying to make here is, because these are tools that we're providing to an agent, like we invented them, we have to be very clear and descriptive about how the agent can use them properly. And if you don't provide the allowed values, then permitted values, then the agent's going to be guessing based on what's in its model and what is most likely to happen. And you're going to get a lot of errors. It might eventually get to the right thing, but it's going to take longer in the best case. And in the worst case, it's never going to figure out how to specify the parameters correctly. So just calling that out. Tool descriptions are very important. And then finally, this just essentially passes those parameters along to this Get Security Hub Findings OCSF function that we have, which calls Security Hub Get Findings v2, and then optionally distills the findings to this more concise format. Finally, we have an Analyze Security Findings tool. One thing I'll call out here is that this takes findings as a list of dictionary objects, which is really convenient. FastMCP and strands, they are converting with JSON on the wire to native Python types for you. That's like super convenient. And then we're able to return a dictionary. And just having that automatic serialization, deserialization handled for you is great, because otherwise you have to describe that format, that JSON, like in your Python docs here. So this again passes through to some business logic, which happens to be the only sort of like interesting business logic. So let's talk about that a little bit. So the Analyze Security Findings function, it's about 90 lines. You can check out the actual implementation in the repository, but it essentially identifies the important findings, the high, critical, and fatal findings, sorts them all in that order, or in essentially priority order according to their severity, computes some statistics, and then takes the top most max important findings. So, by default, we're only going to look at 10 findings, because let's be honest, do you need more than 10 important findings to figure out which one you're going to do next? Probably not, but it's configurable. It could be 3, it could be more than that. And then there's going to be some recommendations extracted for the most important findings as well. But the key point is that this is the doc that was returned from the analysis tool that then the agent transformed to that markdown that it passed along to our security agent tool. And that's it, essentially, for the code. What we all saw was code that was executed in the MCP server demo. If you want to ask the agent directly, you can spin up a client for Agent Core and construct a prompt that looks, pretty similar to what you might send over to a Lambda, but the structure is something that looks similar to what you might send to a Lambda. So you can say, let's review the Security Hub findings for account 2222, and then recommend I should address first. That's a perfectly valid prompt to send. And because the agent has those tools configured, it can go out and get the data it needs. Okay, and then we invoke it again by basically sending that payload to an ARN that looks a lot like a function, a Lambda function. So if you imagined that instead of Bedrock Agent Core, it said Lambda, you know what? This looks a lot like Lambda function ARN. We're sending a payload over there and waiting for a response. And that, that we could ask the prompt could ask that the results be returned either as, plain text, which is what our security agent does by default. Well, it's markdown, or as something structured. So that's it. Now, the implementation is fun, but it's not without challenges. So first and foremost, prompt and tool description engineering is a real thing. If your prompts for your agents don't describe your processes and how you want a team member to act, well, it's not like in order to fit in your organization, well, then you're going to get whatever the model happens to think is best. So you need to guide it there. And with tool descriptions, if your tool descriptions are lacking, then your AI agents are not going to know what tools to use when, or they might call with the wrong parameters and so forth. And that'll really reduce the reliability of your workflows. So, spend a lot of time making sure that your tool descriptions are accurate and really inform those agents in such a way that they know what to use and when and how to use them. Context overflow. This is a big problem, and we faced it in this demo application. The OCSF security findings are quite verbose, and we had to optimize and distill the representation to just the bits that were going to be useful in our analysis. And honestly, I think we should probably go farther on that. But you need to be careful about managing what's in the context window. Third, authenticating MCP clients is still early days. So while Agent Core allows IAM and OAuth 2 authentication methods, and that's great. It's lovely that it does that. The configuration on the client side in Claude Desktop or ChatGPT and so forth is a little more challenging. So OAuth 2 is the right way to authenticate people in the MCP space, but the OAuth 2 authentication configurations, at least until recently, were only available in enterprise and business plans. I think that's changing and should be resolved within the next few months, I would guess. So it's currently late September of 2025. So we'll see if that turns out that way. But just know that right now, for this demo, I ended up using the MCP remote proxy to basically have Claude Desktop connect to that. And the remote proxy has an OAuth token, which is good for 24 hours, that identifies my client and, connects to Bedrock using that proxy. So that should all go away, which is great because it's really messy. You have to have node of a particular version, and then you're managing credentials manually. It's no bueno. So plan on using OpenID connectors that are available in Claude and other chat applications. I want to leave you with the message of go build. You can build useful tools and agents today, and those agents can do a good job. They may not be perfect, but neither is your existing process. And I encourage you to just look around and see what is it that we could analyze, that we could automate the analysis for, so that we can focus on fixing instead of gathering data and finding. Second, codify your logic and integrate your context. So, every organization has their certain ways of doing things. You have particular data sources and so forth. So, because these AI automations are relatively easy to build, and they're relatively easy to integrate various data sources via MCP servers and custom tools, you have the ability to quickly mash things together and build internal products or even external facing products that really match the set of tools and your workflows very closely. And you can do all this, recommend, think about how to start with this. And one way to start with that is by automating repetitive analysis tasks that require a bit of fuzzy judgment. Maybe it's not entirely, prioritizing security findings, that's not necessarily something that is easy to automate with just straight Python. You want to integrate some intelligence into it. And that's where the AI model comes in and your security agent prompt comes in. Like you bake intelligence into that. You bake intelligence into your analysis tool that focuses the issues on the areas that are important to your business. So with that, I can open up some questions. Just a reminder, the code is all available on GitHub. You can check that out. Okay, cool. Just want to thank you for coming. If you'd like to chat about this or other cloud security topics, feel free to hit me up at skenzli@k9security.io. And I'm also available on LinkedIn at Stephen Kuenzli. Love to connect with you and chat anytime. Thank you. And go fast safely.